All right, so today we are doing P1 set notation. So even though it's in the chapter 1 stuff, this is actually prerequisite 1. So it's kind of like the prerequisite beginning stuff of your textbook. So it'll be before the chapter 1 stuff if you look at the textbook. But we're going to talk about inequalities, interval notation versus inequality notation, graphing intervals, and then differences between sets and unions, or set unions and intersections. So first here, pause this quick and write these two inequalities into symbols. All right, so if we want y to be negative, that means y has to be less than 0. It needs to be a negative number. If we want b to be at most 8, that means 8 is the biggest it can be. B needs to be less than or equal to 8. And then the last one here, b is within 4 units of 10. So if we're within 4 units, so this is 10 here on the number line, we can go 4 up to 14, or we can go 4 down to 6. So we want 6 to be less than or equal to x, which is less than or equal to 10. All right, so interval notation versus inequality statements. So interval notation is this column right here. And it's basically using parentheses and brackets to write your inequality. So parentheses is the same as like greater than or less than, and then your square brackets includes your equals to. So if we're looking here, if we have the interval 4 to 10, that's saying 4 is less than x is less than 10. Because we have the parenthesis, we do not have a square bracket or the equal sign. Here's another example. You have 25 to 38. So 25 is less than or equal to, because it's a square bracket, x, which is less than or equal to 38, again, because it's a square bracket. So pause this video quick and do the next two as an example. First practice. Okay, so if we're going to write these, we have negative 2 is less than x is less than or equal to 9. Again, you want to have this matches up with this. There's no equals to. And the bracket right here matches with the equals to sign there. All right, so the next one, you'd have 5 is less than x is less than infinity. Or you could also write this as 5 is less than x, because x obviously can keep going on to infinity. So next we're going to graph some intervals. So this is basically like graphing on a number line. As a reminder, an open circle is the same as your less than or equal to. A closed circle would be your brackets or your equal to signs. This is your parentheses as well up here. So if I want to graph this, I'm going to draw my number line. We need 4 on here, we need 10 on here. So if we're saying 4 is less than x, there's no equal to, so we want an open circle, a closed circle at 10, and that would be the graph of your interval. So a couple more examples. Pause and try these two on your own, and then we'll talk about them. You have negative 2 to 9, and then 5 to infinity. All right, so start by drawing your number lines for both. Here I have negative 2 and 9 and 5. So if we do this first one, at negative 2 we have an open circle, and then at 9 we have closed. So again, parentheses is open circle, the bracket is closed. Here at 5 we have an open circle, and then we're just going to keep going on forever. So you can just draw like this with an arrow. All right, so definition here. A set is a collection of objects, usually numbers in math, but it could really be anything. You could have a set of all the blue cars in the parking lot, or a set of everyone who comes on Zoom. But it's just a collection of something. And those objects inside the set are called elements. So if we were talking about blue cars in the parking lot, an element would be one blue car. There's 3 main ways to actually talk about sets. So the first one is set notation. This one you just list all the elements. So an example, you're going to want to do curly brackets. If we have a set 3, 5, 8, and 17, this would be written in set notation. So we just listed them all out. Each of these numbers would be an element, and then the whole thing together is a set. So the second way you can write it is interval notation. Here you're just writing a range. So if I wrote 3 to 17, this would be the set of all numbers between 3 and 17, not including 3, but including 17. And then set building notation, this one we won't use very often, but I'll write it down so you can see it. You're going to do a curly bracket and then x, like this. So this set builder is exactly what we had right here. It's the same one. What this is saying is you're saying for any x, so for any x you pick, this second part has to be true. So for any x has to be greater than 3 or less than 17. This line right here is kind of an abbreviation for such that. So if I read this set builder notation, it would say for any x such that 3 is less than x is less than or equal to 17. All right. Next, unions and intersections. So here, U, like this, means union. It's the combination of two sets. You can think of it as an OR. So you would be OR if we have two sets. So we'll just call them in circles. This is A and this is B. If you're doing the union of them, you're saying anything in A or anything in B or where they overlap. So this would be like A or B. You could write this as A union B. So the next symbol here means intersection or intersect. This is saying you're only using the shared parts. Or in terms of our Venn diagram, if I draw these out again, we have A and B. We're only looking at this part right here. So this would be A and B. It needs to be in both, or A intersect B. All right, so some examples with this. Unions and intersections. So here we have some sets. A is 1, 2, 3, 4. B is 2, 4, 6, 8. C is -5, 0, and +5. So think through this, look at this, pause, and then write what these actually mean. So this is going to be A or B. So you want anything that's in A or anything that's in B or anything that's in both. So we want all of them all together. So 1, 2, 3, 4 is an A, and then we can add 6 and 8 from B to get all of the sets. You only list each thing once. So even though 2 is in both of them, you only list it once in your set. Next one, we have A and B. So this is only the things that are common to both. So they both have 2 and they both have 4. So the intersection would be 2 and 4. All right, the last one down here would be A and C. So looking at A and C, what do they have in common? They don't have anything in common. So this would be the empty set. So you can say there's nothing in there. It's empty. You can write it as curly brackets with nothing in them. You can write it as a 0 with a slash through it. You can write it as a set. Anything like that. Basically, there's nothing in that set because they don't overlap at all. They're two separate circles with nothing in between. Last chunk of examples. So now instead of having everything written and just listed out, we have them in interval notation. So these are sometimes helpful to draw a picture. So again, we want A or B for this one. So if I draw a picture right here, I'm going to draw A and B. So we need a 0, a 10, and then going on to infinity for all these. So if we do A, and that's orange color, we want an open circle at 0 and a closed circle at 10. And then B is a closed circle at 10 going on to infinity. So if we want anything in A or B, we want all of this. So we want the entire thing. We want everything. So if I write that out, we're going to start at 0. We can't include 0 because there's no closed circle there. So we'll do 0 to infinity because we want everything in this. We want the whole set. All right, the next one, we'll draw, we have the same picture already, but this is asking for what's in A and B. So it's only what they have in common. If we look at what they have in common, put a little mark here so you can see the color, it's just 10 right there. That's the only thing they share. So you could write 10, you could write it with curly brackets, but the only thing they share is 10. So A and B is just 10. So then if we're going to do A and C, again, this is where they overlap. So I'm going to draw the picture. For A, we have 0, 10, C has 20, and 50. So if we draw out what they look like, A is still an open circle here and a closed circle here. If we draw C, it is a closed circle here and a closed circle here and connect them. And we're looking for what's in both, but they don't overlap at all, so there's nothing in this. Your answer would be the empty set because there's nothing in this set. So the last one is B and C. So draw your line again. B is the smallest at 10, C is 20, and 50. So if we draw them in again, B is a closed circle at 10 and goes on to infinity. C is closed at 20 and 50 and is this chunk. And now we're looking for where they overlap. So they overlap just on this chunk right there. So their intersection is going to be, switch back to my marker, 20 to 50. You don't have to draw the pictures with these. I just think it's helpful. Like you could look at B here and C here and say, well, C is inside of B. Obviously 20 to 50 is in between 10 and infinity, so they have to overlap at all of C. It's up to you. But I sometimes like to see a picture of where do they actually physically overlap. Your assignment for this is worksheet P1, so it should be in the folder on Schoology. Let me know if you have any questions.